Great. Okay. So what we're doing in this call is having a look at adding support for the STM32L431 microcontroller for ArduPilot, or specifically for AP peripherals. And so Mallikarjun suggested that I share my screen and record this in case other people want to learn how to add support for a new microcontroller. All right, so I'll start sharing my screen and show you the basics of how we do this. So, so what we've got, we already have support in ArduPilot for the STM32L496. I added that a few weeks ago, and you can tell that by having a look at this hwdef scripts, which is with the Python database files for all the different microcontrollers we support. And in this, there should be a L496. There it is. Great. So, so I've already done the L496, and I've got an L496 Nucleo. I don't think this is it. It's one of the Nucleos on my desk. I've got dozens of sort of them all over the place. So I got that going. So the L431, I don't actually have a Nucleo for it that's exactly the same, though I do have a 476, which is fairly similar. But we're just going to add the base support for the L431, and then we already have a volunteer to test it. So let me do that. I'll just get rid of some of these other windows that we don't need. So the place I start on doing a new microcontroller is I start with STM32CubeMX, which is the ST tool for working with their microcontrollers. So what I'm going to do, if I had the Nucleo for the 431, then I would have chosen the ST board here for a quick start with that Nucleo. I don't, so I'm going to use the microcontroller selector. I'm going to go STM32L431. You can see there's a whole bunch of different variants. Which variant do you have?
I have RCT6, RC series.
The RC?
Yeah.
Yep, great. Okay, we're going to select that, and there it is, and it's available. We can pick a particular one like the LQFP, that'll do. So let's go with that one. All right, so this will give us our basic setup for this MCU. And first thing we're going to do is start enabling a pile of peripherals. Now, we don't care that the pinout exactly matches what you're using to start with. And so we're going to, for example, definitely enable a CAN port, and it's already picked some pins for that, which is fine. We want to have an I2C port enabled. We want to have an SPI port enabled as a full duplex master, and we want some UARTs enabled. So let's do 1, 2, and 3 UARTs. Now we might enable the SDMMC, say, you know, as an MMC, that'll do. We could enable the other SPIs in case they're useful for extra parts of the clock tree. And we might as well enable the other I2Cs in case they're useful for the clock tree. All right, so great. Now in the system core, we're going to have we're going to set up with a high-speed crystal, so a high-speed external crystal without no LSE. We usually use HSE, not LSE in ArduPilot. They will also support no crystal. Whenever we support having one crystal, we usually support also having no crystal or using the internal oscillator. So this is a pretty good start for what we want to use. And so what we're going to do now is I'm going to go and save this project, and I'm going to put it in here and create a new folder for it, which is going to be STM L431. And what crystal do you have on your board? What crystal are you thinking of using?
16 megahertz.
16. So we're going to make this an L431 16 megahertz. Great. Okay, next thing to do is to, I'm not going to resolve the clock there. I'm going to put in a 16 megahertz clock, and I'm going to tell it to use the HSC. So this is the clock tree setup. We're basically choosing how we get the clock. Now, the L431, where is somewhere here? I've got a L431. What is the maximum clock rate? 80 megahertz. Okay, so what we're aiming for is to get this thing up to 80 megahertz. And we want to do the, use the parallel clock here. And we're using HSC, that's all good. So what I'm going to do is I'm going to put this up to 80 and then use the clock resolver to get this back to 80 all the way. That's all good. And now, so that looks as though it will work. I'd rather actually make this divide by 2 and this times 20 and this times 16, because if we make this a divide by 2, then that means we can do 8, 16 and 24 megahertz trivially just by changing this divider, which makes it very simple in our later clock tree setup to get, because that means that that is 2 times an 8 megahertz. So we can, and the common crystals people tend to use is 8, 16, 24 or 30. And so this gives us a trivial way to get 8, 16, 24 in one setup. All right, so that looks like a reasonable, we have 80 megahertz coming through to all of these. We don't have USB on this. We don't have to worry about the magic 48 megahertz clock for USB. We'll probably use PLLQ. That's a bit high. We're just going to drop that PLLQ down to a reasonable frequency. So we'll use the PLL for in there. P-clock 1 is fine for these sort of ones. P-clock 1, P-clock 1. That all seems reasonable. All right, so I think we're happy with that. So this is our basic clock tree that we've designed. We're going to have to put that into our header file with all these scalars and things, but that seems to be a reasonable clock tree to start with. We're using the P clocks, the PLL clocks there for all of those, and we've got all of the clocks sitting and happy. Great. Okay, so next thing to do is we've got that saved, so we can come back to it. We're now going to export the pinouts with alt functions. All right, so what we're going to be doing is, and I'll just pop it down into temp here, and this is going to be L431 alt.text. So that gets us our basic L431 alternate functions. Great. Okay, so now what I'm going to be doing is we need to create a basic STM32L431.py, and I'm going to be lazy. I'm going to start by 431. I'm going to start with the 496 and then edit it. So L431, and you said it was an RC. Okay, great. So then we just use the same startup, the L4 startup. Now, the L431 comes in what variants? Does it come with in variants that actually do like 144 pins, or is it a maximum? Yeah, so looks like the 431 is maximum 64 pin.
64 pins.
Right, okay, great. So that's fine. So that means just back to our, where we had the MX cube stuff. So our pinout here, we can see that we've got port A, B, C. Do we have any port D in this thing? Are we using port D at all? Doesn't look like we're using any port D. So we're just doing the ABC, but we want to be able to go up to 64. So I think we actually do ABCD, and so we will generate up to that, because there are 64, you're using a 48-pin variant, I think, but there are 64-pin
mine is 64.
variants. Oh, yours is 64. Okay.
Yeah.
So, and it only goes out to ABC. I think we'll allow up to ABCD in here. All right. Now, memory. We need to get the data sheet. So this is the point where I download the data sheet for the 431. So I've got lots of different data sheets here. And I've got a G431. Do I have an L? Where's my, I'll just go and download it. So it doesn't look like I've got that handy. So this is the L431 RC. So pop into there and grab the data sheet. Chug, chug, chug. Slow sometimes, this website. Sometimes very slow. I'll actually, there it is, finally. Okay, so documentation, download data sheet. For some reason, everything's just horrendously slow. Maybe it's the screen share. Stop. Okay, now it's finally clicking up and grabbing it several times. All right, so we're now going to save a 431 data sheet. So transfer, there it is, STM32L431. So we need to know, so it's up to 56K of flash, 64K of RAM. So what we need to know now is the RAM layout. So because we need to start knowing you know, how the embedded SRAM, there it is. There is 48K and 16K, so it's in 2 lumps. So what we need to do is, these are called SRAM1, and so what we're going to do is we're going to say, so 48K, and then the other one is starting at address 1, and that is 16K, and that's SRAM2. This is SRAM1, and we're expecting this to be 80 megahertz total. So we need to now get the DMA. So let's see, is this particular address space with SRAM1? Okay, memory is also mapped. Aha, this is actually dual mapped. Right, that's nice and convenient. So in fact, we can treat this as 48 plus 16, which is 64, and as a single memory region. So we're going to use second mapping of SRAM2 to allow a single memory space. Great, so that's really convenient. Some of these chips double map, so this one's double mapped so that the 16K is aliased directly above the 48K, which means we can treat it as a single one, and it should be DMA capable, so we can just treat it as a single DMA capable lump of memory. Very easy. Okay, so next thing we've got to do is pull in that alt function table. So we'll just delete that one that we've got in here from the L496 because it won't be correct. And then we've got to run a nice little script, tools, scripts, libraries, AP, HAL, ChibiOS, HWDF scripts, and Python 2, and this is the, where is the script? APF parse cube max. That guy /temp /L431, there it is, and we're going to map that to temp L431 AF2.txt, and then we'll bring that into here. Great, now we have the alt function map. Okay, so this is basically straight out of CubeMX. This gives us all of the alternate functions for this chip. Now, some of them we're likely to have to do a bit of cleanup on because sometimes ST isn't quite consistent in their naming of peripherals. So looks like the CAN is okay in this one. But I bet that they have gone, yes, they've gone and changed they've got a slightly inconsistent thing here with the, that one there, and that's the dash SW. So sometimes they use different names here. So I'm just going to make those consistent. Okay, that should be fine. And so we've done that, but that's for debugging connectors, and I could neaten that up a little bit. So there you go, and neaten that up just a little bit. Great, so there you go, and that's all good. So we've got our alternate functions. Okay, so the rest of this file, so this file is basically a little database file that ArduPilot uses to build the header files for ChibiOS. So we've filled in the alternate function map in here, which is so it knows what pins can do what. We have not filled in the DMA map yet. That will, now this is the DMA map for the L496. Now, if we're lucky, it's almost the same DMA map as the L431, but it may not be. All right, so the DMA map comes from the reference manual, and it depends whether the L431 uses the same reference manual as the L496. So let's go and see whether we get lucky. So in our documentation, waiting on very slow network, come on, product overview features, it should have been, I should get a link there to the reference manual. For some reason, this is just horrendously slow clicking links here. Possibly the video sharing, but we'll see. I think I'm going to just try a different browser and see whether it makes a difference. Okay, so I'll just kill off some other things that I don't need at the moment. And let's try documentation here with this one, that we can find that reference manual. Okay, product specification, reference manual, there she is. So this is L414243444546. Yeah, unfortunately, it doesn't look like it's the same reference manual. So this is the, so what I've got to do, so RM, great. RM0394. So this is our reference manual for this series of microcontroller, okay? And it may have a similar DMA map, but not exactly the same. So what we've got to do now is find these DMA tables, which is these ones, and we need to extract these tables. Now, quite often when we're adding a new microcontroller, we don't need to do that. This is one of the most time-consuming parts of adding a new microcontroller. And I've been meaning actually to rewrite this as a Python script that extracts it from the ChibiOS headers, because the ChibiOS header files actually have this information, this table, in a different format as hash defines. I just haven't written that script yet. So I'm just going to have a quick look and see whether they have in fact used a very similar one to the L496. So if we just pick one like ADC1, and if we look for here for say ADC, ADC1 is in 110. Yeah, so no, it doesn't look like it's the same. Doesn't look like it's the same at all. Looks like it's actually fairly different. And so if we go for one of the ones we really care about, like US Art 1, oh, that's my dog saying that she wants dinner. I will just introduce my Cavalier Lara. Hello, there you go. Say hello to the viewers.
Hello.
So she thinks it's dinner time. So I'll actually just pause the recording for a second while I go. I've got to give her at least her heart tablet. So hang on a second while how do I pause this recording? Stop share. And so I'm going to, so continuing the recording, I'll start screen sharing again and we'll see how we go. So, so one thing I notice about this table is this table is not in the same format as we had for like the F4s and F7s and, you know, F1s and F3s and all of those. It's a slightly different format, which does mean that the little Python script I've got that extracts this is going to have trouble with it. And whether it's worth it, as I said, I've been planning to write a new Python script that goes and extracts it from the ChibiOS headers. So it's going to toss up whether it's faster to fix, it's going to be faster to fix the Python script to cope with this different format of table, or whether just typing in these few numbers will be faster. But anyway, I'll show you the Python script extraction. So to do the Python script extraction, we first of all have to pull out these pages of this table, and notice how they're split. So we've got to pull out, so this is page 298 and 299 as to a separate PDF, right? So let me do that. And so what I'm going to do is I've got this little PDF extract script, and I give it the in-file name, and that is the RM, that one there that we've just downloaded. And then the page start, so this table starts up here on page 298, page end 299, and out file, so I'll call it STM32L431 DMA.pdf. So what that does is that just extracts out those couple of PDF pages into a smaller PDF. And the reason we're doing this is the tool we're going to use doesn't like big PDF files. So extracting this out to just be a couple of pages saves time. And so it's, once it's got it extracted, we just make sure we've got the right pages. No, that is, we should have ended up with, oh yeah, that is actually correct. It is just those two pages. Yes, there's that table and that table. It's just that it's included the index for the whole thing, even though we don't have that index. Okay, that's fine. All right, so good. We've now got a PDF which covers just those two pages. Okay, so the next thing we do is we go into Tabular, and now which was the latest? It's so I go to Tabular there, and I do java -jar tabular.jar. All right, so this will launch Tabular, which is this little Java tool, which is now dying on me, of course, when I'm demonstrating it to people. Why is that dying? Let's see, address already in use. Aha, okay, so who is using 8001? So I think it's probably, I've probably got an SSH going. And do I have an SSHD? Yeah, I've got, I was using redirections, port redirections of port 8001. So I either need to convince this script to go on a different port number or convince SSH to give up that port. System control status, SSH, and it's probably SSH. Is it going to be SSH agent or SSH service? System control restart SSH.service and netstat -inp or grep 8001, and still listening. Oh no, it's actually Apache. I can see it there. It's Apache. So stop Apache 2. All right, now it's no longer listening. Great. Okay, so now I can go and run Tabular again, and hopefully that will start up. And so once it's started up, I'm going to connect to 127. That should be available as HTTP. Can't establish a connection to the server 1001. Oh, it's 8080. Aha, it's come up on 8080. Great, now I'm in Tabular. Excellent. So now I go and browse a PDF file. It's already got the right directory. There's the little file we've already created. So I'm now bringing that in and importing that one. So importing that couple of page PDF into here. And now I see there's a bunch of tables, and I'm going to just click the auto detect tables. Right, so there's our tables that we want to extract. Now I know from bitter experience that padding around these tables makes it far more likely that it's actually going to extract them correctly. So I'm just going to pad around these tables a little bit. And great. Okay, so we've now got that, and I can never remember. Let's see, preview and export. So there we've got our table data. All right. Now there's two different ways of doing the extraction. We can extract it as a stream like this, or as a lattice. Lattice is doing a lot better. So let's use lattice. And but notice it has broken it into multiple tables. All right, so what I'm going to need to do now is export this as a CSV. So that is now got this tabular CSV file. All right, so that's where I move that. And there. So there's our tabular STM32L431.csv. Right, so this is the thing we've got to now go and process to create that, that section of our little Python buffer we were dealing with, this one here, this DMA map. Okay, now by the way, if you are adding support for a new microcontroller, if possible, pick a microcontroller that has what's called a DMA mux, like the H7 has. Or because life is so much easier because you don't need this DMA map, because every peripheral can use every DMA channel. And life is much, much better. It's much more, a much nicer way to go. Unfortunately, these lower end microcontrollers don't have that. So we've got to muck about, stuffing about with this DMA map. All right, but meanwhile, let's see how badly our little Python script does on this. And I'll just, so we've got this little script, libraries APHAL ChibiOS HWDEF scripts, and it's called DMA parse. Now, I did do a whole lot of changes to make it support this new format, but I'm not sure that I've saved those. So I'm just going to pop a few of my stashes here. No, so git diff, so I'm going to reset that. This show -p. I may have it in one of my stashes. You know, the updated parser. It could also be in one of my other working directories. Git stash show -p. No, drop that one, because I did actually go to the trouble previously of fixing up this Python script to cope with this new format. And unfortunately, I appear to have, damn it. So locate DMA parse.py or xargs ls -latr. Could be that I've actually got it sitting there somewhere. And let's see, what the most recent I've got was from September the 29th. And I do have one from September the 19th here. That might be the version that fixed up to cope with these L4 things. So I'm just going to yes, that actually could be it. So I'm just going to copy that to /temp and go back to where we're doing, and diff -u libraries APHEL ChibiOS HWDF scripts DMA parse /temp /DMA parse. No differences. Okay, we'll have to just cope with ourselves. So what I'm going to do is try and run this little parser and see how well it does. And I think it's Python 2. And we're going to run it on this data sheets, STM32, DMA, STM32, tabular, STM32L431.csv. Yes. Okay. So the first thing that is different about this one is it's 7 channels instead of 8, right? So this is where I'm kicking myself because I did fix up this script to cope with all of this. Then I thought I wouldn't need it again, and I've thrown it away somewhere. So, all right. So all the places where we're dealing with 8, we're going to be dealing with 7. I really should have a parameter to it. 7, and it's one of these things. It's one of these sort of throwaway scripts you write, and then you end up rewriting it. So let's see whether that gets any closer. And so let's see. So we're going on line 27, and row equals stream +1, print. Right, what have we got here? So we've got channel 1, channel 2. Yes, that looks good. And that's right. They're actually 0. I think the channel numbers go 0 to 6. So I think what we want is that. Yes, missing channel 0 for DMA table 0. So we have actually parsed it and it hasn't died. And now it's just complaining that we're missing some channels. So what I'm going to do is have a look at what we've ended up with as a table. So let's have a look here. We're parsing that table, check full table, and so this is the table and print table. So what have we actually ended up with here? So what we've ended up with is 1, we've got 101, 3. Okay, so what this is completely missing, this is not getting the device IDs. Why is that not extracting out the table? That's just pulling out the tables. Yeah, but it's labeling them as just sort of 1 colon. That's not right. So it definitely has not parsed this correctly. Yeah, okay. So this is the problem. If we go and have a look at the PDFs for one of the other ones, like if I bring up the PDF for, say, I don't know, the F732, then what it shows is stream 0, 1, 2, 3, 4, 5, 6, 7, and then channels on this column. So this is the format that Python script was designed to parse, right? Notice that it's inverted, the streams versus channels, right? Which is really annoying that they've just changed their nomenclature. So what we're Whereas what they have got in the 431, we've got these channels, and then these are the CS numbers, right? Which are really channel numbers, and the top things are the streams. So that is very annoying. Now, what I might do, I mean, maybe I'll just go and edit the CSV file, and forgotten what I did exactly last time when I did this one. It was only a few weeks ago, but of course my memory is failing me. Data sheets STM32, and we will grab DMA and tabular L431, and we're going to replace channel with stream. Okay, and what we expected was more like this other PDF we had over here, which is these first columns are channel numbers, right? And channel 0 and 1 and 2. This actually, that's another whole header. So channel 2, and they've done them as this sort of binary encoding rather than as digits like they did in the other ones. You've got to sort of love the way ST changes their formats. It makes it a bit harder for the machine parsing. Channel 6, channel 7. Okay, great. And then this is more of those streams. And then we're going to do channel 0, channel 1, channel 2, channel 3, channel 4. Say we just about type in the whole table manually instead of having this parser. Channel 5. Is that actually a 5? That was a 6. And there is a 5. Great. And then channel 7. Okay, let's see if the script gets slightly happier at that. Aha, now we have a DMA table /term/d.text, and we will then go and double check that it looks reasonable. So let's go and cut out this DMA map and go and put in that one. So it's, that's that print I had in there, and there's our DMA table. All right, now some of it looks pretty weird. Let's go and check the key things. So if we've got, that's the 732. If we go and double check this guy here. So ADC1, 110, that looks right, and 230. So that's table 2. ADC1 has got to be in here somewhere. There it is, table 2, 30. Yes, that is correct. Okay, so that looks right. I don't know what this is this stuff at the top is all about. This looks complete rubbish. I2C1, let's just check that one. And I2C1 RX. So if we look for that, that's I2C1 receive. Yeah, see, it's actually only showing one. It's not showing this. I2C1 receive is available in table 1, 7.3. And some reason we haven't ended up, it hasn't parsed it correctly. Bugger. Why is that not parsed correctly? And it's somehow got this stuff in the CSV wrong. Let's go back and have a look at that CSV again and see what the formatting we had was incorrect there. And so that looks right. That all looks reasonable. The script is supposed to cope with all of this sort of funny formatting, but I'll give it a helping hand. And we don't need that. That's just fluff. And that's just fluff. Okay, channel 2, channel 3, channel 4. So that's supporting 2 different things there, which is, I think that looks right. And then we don't need that one. And let's see. Let's see whether that produces a better table. So we've still got that print. Get rid of that print table. All right. So it's still giving this 0, 1, 2, 3, 4, 5, 6, 7. And those labels are complete rubbish. And I think I know we did need that stream +1. I think that's starting to look a little better. Okay, so ADC 100 and 220. Let's have a look. 100 and 2. Table 2. Nope, that's still not coming out right. So ADC 1. Oh, it is, you're subtracting 1, so it is actually 2. So that is actually correct there, but we need to work out whether it's 0 indexed or 1 indexed. On the L4, what I need to look up is whether there is a +1 in ChibiOS for the DMA stream. And okay, DMA, it's called DMA stream ID and modules ChibiOS, git grep DMA stream ID. And if we look at grep, then DMA stream ID, okay. And so on the DMA v2, it's DMA -1 × 8 + stream. And we need to look up whether the L431 OS HAL ports STM32L4 platform to them make, it uses DMA v1. So it uses the DMA v1 macro here, which is DMA, and it is indeed the stream -1. Right. So that means it is subtracting 1 off that. So that means that we should not be using 0 indexed IDs in that DMA parse. So this number should be 110, not 100. Okay. So what have I done to this script so far? And okay, so that means that that table should be like that. Let's try that and see. And now when it says missing, okay, so we know it's not missing 8. Great. Okay, so that means we've now got ADC1 as 110 and 230. So 110 and 230, correct. Great. ADC2, 120 and 240. 120, yes, and 240. 240. ADC2, yes. Okay, we might be cooking with gas here. So we've now got I squared C1 receive is 173. I squared C1 receive, and let's see, is 173. Yes, that's correct. There's the 3, and it's also on 265. So 26. Yes. Okay, so that appears to be working. Right, now, the good thing is that if you get this wrong, it's not completely disastrous, because the DMA just doesn't work for that particular peripheral, but you discover that, you know, very quickly on a particular board. So if there are errors in that, but my guess is that's actually pretty good now. So let's go and have a look. Let's replace that DMA map with the one that we've just I'll just pause once again because my wife just got home, and I'm going to make sure that she knows the dogs have had their heart tablets. So I'll be back in another minute and resume recording. Great. Okay, so that's got that reasonably well cleaned up. Sorry that was so messy. This was a lot easier when we were doing like the F4s and the F7s and the F3s. We had that DMA script that got it all right for all of them, and it was a very simple process. As you can see, you know, that's like looking inside how sausages are made, and that was really horrible having to hack around that. But we've ended up with the table, so we can now keep moving. All right, so we've got ourselves a DMA map. We've got the alt function map. The only part of this table we haven't got yet is the ADC map. Now, we haven't actually enabled any ADC pins on this, but I'm just going to go into the data sheet, and it could be that we get lucky and our ADCs are already correct. But let's go and have a look. So 1_ in 3, say. Okay, here's our table. So this is how you find out your ADC. So these tables here, and they're usually in a pattern that's much the same. So here we have PC0. I reckon this is probably going to match up with existing ones. So PZ0 is ADC1 in 1. There it is. PC1 is ADC1 in 2. Yes, looks like it's going to be the same. They usually copy the block. So PC2 is ADC1 in 3. PC3 is ADC1 in 4. We'll just check the rest of them. So we've got ADC1 in 5. If I change that to a 5, there it is. And that's on PA0, yes. And 6 is on PA1, and 7 is on PA2, and 8 is on PA3. They're all going to match, I'm sure. 9 is on PA4. 10 is on PA5. There it is, 10 on PA5. And 11, are we going to find 11? 11 is on PA6 and 12 is on PA7 and 13 is on PC4. That's correct. And 14 is on PC5 and 15 is on PB0 and 16 is on PB1. There you go. It was all no changes at all. So that was nice and easy. Our ADC map between the 496 and the 431 is exactly the same. Okay, so that means we've now got our Python database for the 431. So that gives us our basic support. So the next thing we want to do is make up a board. So we've got to create a bootloader and a board. So shall we create your board? Do you have a schematic for us to use to create the first board, or shall I just make one up? What shall I do for a schematic?
I've actually made STQ pin layout.
Right. So if you can give me the schematic, and you can either do it by you could give me a cube MX file, or you could just tell me the pins and we could create them. For the basic bootloader, it's very simple. So so if we do something like Nucleo L496, what I'm going to do is of course, again, because I'm a lazy programmer, laziness is one of those things that programmers need to be. L431 and L496 that to L431. So L431. Great, we're going to do the bootloader first, and all I've got to do is say that that's a L431 and an L431. Okay, great. That tells us to use a 30. Now, we've got to decide where we've got the bootloader. How much flash have we got on this? It's pretty low, isn't it?
256K.
Oh, heaps of flash, oodles of flash. All right. So I'll just close off Discord so we don't get interrupted there anymore. So we're going to have a bit of space for parameters. We're going to have a 36K bootloader. That should be plenty. Now, what is your board called?
I haven't named it yet.
Well, you got to have a name, because I've got to give it a name in here. We've got to add it to the board types. So AP hardware, give me a name.
Sierra L341.
Was it?
Sierra SIERRA.
Yep.
L431.
Okay, L431. Great. And SIERRA, is that correct?
Yeah, correct.
Great. 1050. So congratulations, you've just been allocated ID 1050. Okay, so we've now got a 1050. We put that in the board ID here. We're going to set it up as a peripheral. I'm going to initially, you said you had a 16 megahertz crystal, didn't you?
Yeah.
So I'll put you in a 16 megahertz crystal. We'll also add support for an 8 and 24. So we're going to assume a 56K part. We'll stick some standard out debugging on SD1, and I need to either get a schematic or start getting pinouts here for what UARTs and that sort of thing you want. How do you want to give that to me?
How do I share it? Should I share it through Discord?
Yes, you could share it to Discord. Send me a file. Is it a CubeMX file or what?
I've actually made hardware definition files already.
Oh, great. You have. Okay. You can just share that. That'll save a lot of time. And then we can try and build it. So if you just send me there it is. If you just send me an hwdef.dat and a bootloader file, then I can steal those and we'll get going. So maybe a lot of the stuff I've done earlier in this video call you'd already done. Had you already done that database file?
I had done only the hardware definition files.
Right. Okay. Well, you send me those here, and I will put them in place. All right, so there's, and we'll save that. And we will save that. Great. And HWDEF start to L431. Great. All right, so now we're going to reopen that. There's our L431. Great. And we've just allocated you an ID of 1050, 16 megahertz display flash. You've got a couple of UARTs in the bootloader. You've got a fault lead. All looks good. We don't have USB on this. We can just delete that. Serial 1 and we'll use UART1, UART2 there. Serial buffer size all looks good. Stack looks good. Empty storage for the bootloader. We're using a CAN port, just one CAN port. We're adding debugger support. We'll put the CAN one silent up next to the CAN ones just to sort of logically keep them together. Timeout, DMA and Sierra-L431. And now I put this as a nuclear, so I actually got the wrong directory. Sierra L431. And so I should have put it in that directory and great. Great, all gone, all good. So we've now got that, and we've got ourselves an hwdef.dat. So we'll just build the bootloader to start with. Now, this won't build initially because I had a bit of a peek earlier, and it looks like the registry file is not properly filled in for the 431 in ChibiOS. So it means that for most boards, at this point, you can just go ahead and you're all, you can start building, okay? But I suspect in this one, we're going to need to tweak the STM32 registry in ChibiOS, but we'll see. So we're going to do WAF configure -- board Sierra L431 -- bootloader, okay? And I'll do it without debug. We'll just do a straight build. Okay, so that went so well so far. And WAF bootloader. And I normally run it with nice just to not disturb the processing, and lots of errors. That's what I was expecting. So if we go and compile these, all right, and I do NAS bootloader, bring it up in here so it's easier for me to find the error. Yeah, STM32L4XX device not specified. Great. So this is, we need to go in and add the 431 into this list, right? So what we're going to do is notice it's only got a subset in here. And we're going to go in and add that for 431, and that'll do. So let's recompile, see how much closer we get. And okay, clock has, right, this is because we're missing the registry file. And so in this registry, we've got the L432, but we don't have an L431 in here. Okay, so what we need to do is go, and we're going to start with the L432 and tweak it if we need to. So let's go and do that. And now this is one you don't have to always do this because usually the registry file's already done. And I'm just going to check in a later version of ChibiOS. Let me go and check whether in this registry file in the trunk ChibiOS, whether this is already done. ChibiOS svn ChibiOS.get svn oshal ports STM32L4 registry L431. No. So this is something we're going to contribute to ChibiOS. We're going to add the L431, and so that's going to be 432, 431. Right, now we've got to make sure all these defines are correct. Okay, so what we've got to do, now that's probably going to be the same as the 432, right? They're the ones, the neighboring ones are usually extremely similar. But we just got to go and have a quick check. If you're sort of impatient, what you can do is just jump ahead and compile like this and see if it works. But if we want to actually get it right, we've got to do a little bit more. So back up in sort of the functional overview. This is basically, this registry file gives the capabilities of this microcontroller, okay? And does it have an HSI 48, right? And it probably does. Well, we could see that from the, somewhere here, I had the CubeMX. And on the clock configuration, there's the HSI 48, right? It is actually in there. At least CubeMX thinks it does. It does have ADC1, and now the DMA mask, this almost certainly has the same DMA masks as the 431, because within a family, they just always get those the same. We'll just double check a couple of them. So I'll just create a new frame here and switch back to our STM32L back here. Libraries, AP, HAL, ChibiOS, HWF scripts. I'll just spot check some of these and the DMA. So ADC1, 110 and 230, 1123, yes. So they are using the same basic one. And let's have a look at another one. I2C1 receive DMA. This is what I was planning to write a Python script to process, because that information we're extracting from that darn CSV file and out of the PDF is actually already in here in ChibiOS. So I2C1 RX, I2C1 RX is 173 and 26, yes. And the fours, that's these numbers here, give us the channel mask, but they're the same. Yes, it's clearly the same. So I'm just going to jump ahead and we'll say now, first of all, we need to know, does it have an ADC2 and an ADC3? ADC2, and it does, it has a DMA map for ADC2, but there's no ADC2 mentioned in the out function map. It doesn't need to be in the out function map, of course, the DMA. So let's see whether it does have an ADC2 on this one. So we look under ADC, better device, analog digital converter. Looks like it's a single one. It only mentions one ADC converter. Otherwise, it would say it has 3 ADC converters. All right, great. So it only got the one ADC. Now, the CAN. Let's have a look at the CAN capabilities. And we can see that CAN, it has a single CAN peripheral. Great. And it's almost certainly the same CAN peripheral as the others. We could look at the max filters. And we can already see there it said max 14 filters. I just saw it fly past. That's fine. Okay, great. The DAC, we're not actually using the DAC, so we don't care about that. We can leave that for the moment. But we should, before we submit it up to ChibiOS for inclusion, we'd have to make sure the DAC stuff is right, but it almost certainly is. I guess we could go and look it up now. might as well. And that's the digital to analog converters and functional overview DAC. 2 12-bit, so it's got 2 DACs, which is fine. That's what we got, and they're both 12-bit buffered, and the DMA channels we've already decided are going to be the same. Great. Advanced DMA, and yes, it will be the advanced DMA, and it supports no DMA mux. Pity it doesn't. DMA1 number of channels, they're both 7. We saw that from the table earlier. We don't have Ethernet. We've got 40 XDI lines, almost certainly the same. We have GPIO A, B, and C. Okay, so it only has A, B, and C according to this. Let's have a look at GPIO in here. We might remove that D from our other script. And nested, it probably is just A, B, C, because, so I think I'll actually go and change this one and get rid of, I'll say we've got 0 pins on D. All right. We have, there's our mask, that's fine. I2C1, these will all be the same. And does it have an I2C2 and 3? So it's 3 I2C. Okay, so it actually has 3 full I2Cs. All right, so that means that it's not quite the same as this 432, which only has a single I2C. And I2C2, so it's going to be more like, what is this one here? That is the 433, yes. So what I'm going to do is steal that one there for the extra 2 I2C2 and 3. Okay, so that gets us our, we actually already had I2C3, and then we want I2C2 and I2C3. We don't want to double define that. All right. And okay, that's all good. Now, next thing we can have a look at is quad SPI. Does it have a quad SPI? Not that we're likely to use it at this stage. And quad SPI, it does have quad SPI, great. And STMMC, does it have STMMC? You know about it? You've been using STMMC?
No, I have not been using it, but I have opened CubeMX, so I have all the things listed out.
Okay, great. And so we're going to steal, has it just got STMMC 1 or has it got 2?
1, yeah.
Just 1, great. Okay, I'm just making sure I'm still inside the 431. So there's our STMMC. Now, SPI1, how many SPIs does this thing have?
3 SPI.
3 SPI, 3 SPIs, great. So there's SPI1, SPI3, SPI2. And SPI2, it'll be the same as that. And okay, great. Timer. Now, how many different timer channels can it support? Where's our timer? Tim. Anyone see Tim? Anyone seen Tim? Tim. Oh, come on. For some reason I just go blind and can't see pieces in timers and watchdogs. There we are. Okay. So if we have, let's look at the basic features. 1 advanced timer controlled up to 5 general purpose timers, 2 basic timers, table below, there's timers, basic timers. All right. 3-phase, it's probably 6 like all the others.
6 timers. There are a couple of low power timers.
Yeah, which we don't care about so much. So now we do need to know which one's a 32-bit, however. So that's quite important. Is it TIM1? Is TIM1 32-bit? Where's the... TIM2 has 32-bit. So TIM3, 1516 is 16-bit. It probably only has one 32-bit, but it doesn't. So TIM1 doesn't say whether it's 16 or 32-bit. 6 channels, yes. So that's, we were correct about the 6 channels. Well, if it doesn't say, I'm going to assume it's, here it is. It's up here, 16-bit. Great. So TIM1 is 32 bits false. TIM2 is 32 bits true. And then we've got, so we've got TIM1, TIM2, TIM6, and 7, which are both not 32-bit. That's great. TIM6 and 7. Capture channels. Okay. And channels, TIM2, channels 4, TIM6, 0, and 7, 0, and the capture channels 6 and 7. TIM15 is 16-bit, and TIM16 is 32-bit, and there's 2 and 2. So 15 to 16 looks like is only 1. All right, so that gives us our timers. We're nearly done. Now, UARTs. What UARTs does this lovely little microcontroller have? So UART.
There are 3 UARTs.
There it is, UARTs. Okay. 3 embedded UARTs, UART1, UART2, and UART3. Okay, so let's see, it's got USART1, USART2, and USART3. So we just need the USART3 from this one. And there it is. And it does have USART3. Great. And I'm just copying the DMA masks, and I'm assuming that's correct, which it almost certainly is. Before we submit this up to upstream ChibiOS, we should actually double check these things. All right, so that is all good. Now, does it actually have OTG for USB, or does it just not have it?
No, it doesn't.
Doesn't see OTG, has USB, false. So let's go and pinch one of the others that doesn't have USB and have USB, false. And this USB doesn't matter, and that doesn't matter, and that doesn't matter because we said USB, false. OSD, OTG1, false, OTG2, false. Great. Okay. Independent watchdog, they've all got an independent watchdog. So yes, I assume it does. Let's go and double check. But if it'd be very annoying if it didn't have an independent watchdog. I haven't met an STM32 that doesn't have it yet, but there may be some. Can you see timers and watchdogs? There it is. IWDG. Yep, it has it. Great. LTDC. Now, I've never actually dealt with an LTDC, so let's see if it does have one. And LTDC, if I search for that. There is no mention of an LTDC. Well, it says false there, where it's false and false. So false, false, FMC has CRC. It almost certainly does have a hardware CRC generator. Let's see if it is mentioned here. CRC generator, yes. Okay, we have a 431. That is great. And so now we will still need to grep L432 star H star C. So we will need to, here, we need to add support in here. So in for this one here, L431. L31, let's just make sure we've got them all. This is just a comment, L431 XX. Great, and we've got that one in there. We've got that added in there. And we've done the registry. And that should be it. All right, let's see whether we can recompile now and get any closer. Hey, ChibiOS builds, ChibiOS kernel builds. All right, so, and the bootloader builds. How about that? There you go. So now what we're going to do is board, which folder am I actually working in? apm.chibios. I'm in the wrong window here. There it is. And board without the bootloader. And then I'm going to build AP perif. And let's see if it, oh, there you go. Timer used. Okay, we've got to shift timers around. So we've got ST requires TIM2, but timer is already being used. So remember when we were back at that registry and the L431, we had the list of timers. So we can just shift up that in that HWDEF. HWDEF Sierra L431 timer, because using timer 2 there, right? And so TIM15. So if I look at forgotten the syntax we have, timer, yeah, system timer. So we're going to use timer is 12. Did we work out that 12 was a valid timer? Let's see. Functional overview, timers and watchdogs. Tim, no, we're going to use, say, 15. Looks like a lovely timer. So use timer 15, and resolution is 16-bit, right? So we don't get a 32-bit timer. And that's fine. So we're going to reconfigure that and see whether we get any further with this build. Okay, we're still getting errors, spewing 1,000. Yes, yes. You know, to stop throwing errors. STM32 ST use timer redefined. Now, why is it doing that? Aha, okay, we've forced, we've just got to have an if and def around that. Come on. Okay, specifies an unsupported timer. Huh. So it's claiming that how ST, so okay, so the system clock in ChibiOS for the L4, so this is TIM v1, doesn't support that particular timer. Now, what we can do is we can use one of the other ones. It supports, let's see, which ones does it support? So, so timer used equals 2. So it'll do 2, 3, 4, 5, 9, 10, 11, 12, 13, 14, 21. Annoying. And there's no overlap here. So we're going to have to actually do a patch in here to the HAL STLD to add support for one of these other timers like TIM15. right, which is slightly annoying. That's going to be a slightly larger patch for this microcontroller. That doesn't usually happen. So what we're going to do is it'll be basically the same as, say, the one for 13. So TIM13, and so what we're going to have to do is add in fact, we're going to make it, we use 14, it's just increment by 1. So it's just monkey see, monkey do here, and like that. Now 15, it's got capture, compare, channels, complement. Yeah, so that should do. It's a counting up only timer, but that's okay. I think we only need to count up we're just running a free running timer. So there we go, we've got 15. So I've got to find all the other 14s and duplicate it to 15. And it's all rather tedious, this. It'd be nice if this was sort of generated from like a macro, but it's not in ChibiOS. So it's actually just done as if defs for each possibility. So we need to do some mucking about. I could, by the way, check, we might be able to short circuit this. Back on your HWDEF, so you're using TIM2 for PA for an LED, PA15 and PB11, all right? So what we can do is we can go and look, see whether they've got 2 timers. So this pin only does TIM2, damn it. PB11, it also only does TIM2. Okay, so we do have to free up TIM2. So we do have to make one of those other timers work. So I was just seeing if I could find a shortcut here. So TIM15, TIM15, TIM15. It's like an n squared thing, this. It's rather annoying. And there's the 14. We've got to duplicate that whole 14 to be a 15. And then I've got to query replace 14 with 15 in here. And then we've got to fill in the 14 like that. And then down here on this, we've got to keep going the pattern into 15. We're nearly done. Okay, let's try and recompile that and see if we get a little bit closer. All right, error, an unsupported timer. Damn it, why is it still saying requires an unsupported timer? So that should have gone STU's timer. I thought I set it back to 15. HWDEF Sierra L41. Use timer 15. Yeah, that's right. And I didn't end up with 15. Have I just undone? There's 15. There's 15. LF timer equals 15. Yeah, that's all good. Ah, that's the STLD. TIMV1 STLD. So which, let me just see, which header file was it actually complaining about? It's the HAL STLD.C. The .c file, right, equals 14 in here. We've got to duplicate that for equals 15. 15 and query replace 14 to 15. All right. So let's see whether that gets us any closer. Okay, so we've got a warning there. Debug MCU, AFB, DB15, TIM15, stop. All right, so we've got to look up. We need to know what the yeah, this is only when you for the debug, which actually doesn't all that matter. So when we're stopping the CPU. Okay, so I need to find out what that uses. So I'll just go into apm.ChibiOS modules, ChibiOS, git grep, and what we want is the grep -i L4. So 43, there it is. So that's what we want. It's just that it's on a different part of the bus. It's APB2FZ, APB2FZ, debug TIM15 stop. All right, and it'll be the same. I've got to look for debug TIM15 431, and that is the same as it has to be, APB2FZ, APB2FZ debug 15 stop, and then this one, so debug TIM15 stop. So this one here, let's see. Actually, it's going to be APB2FZ. Great, because it's going to be on the same bus. Excellent. Okay, so that might get us a little closer. Let's see how we're doing. Okay, ChibiOS builds for the main firmware. So we're coming along nicely. So this is a much harder one than usual because the 431 wasn't explicitly supported to ChibiOS up till now. So we've had to do a lot more hacking than you would normally need to do for adding a new micro, because most of the ST micros are already supported by the base ChibiOS, right? So we've been hacking this in to add it on. Okay. So that is building. Right. PAL32 O speed. Interesting. Okay, so we need to look up the GPIO speeds. So this is during serial ESC COM. So this is for doing things like DShot, right? Now you're not doing DShot, so we could actually just say disable serial ESC COM, but it's probably that our GPIO speeds are wrong. So what I need to do is bring up that reference manual and look up the GPIO reference manual, or I could just look it up. It might be easier to look up the macros in the headers. Git grep and grep -i L431. L4, there they are. Okay, so is it? So it's not got lowest. Yeah, so GPI V2, let's go and have a look up which HAL this uses. So this is STM32L4 platform.mk. The GPIO, it uses GPIO V3. There's our problem. Right, so GPIO V3 calls it low. If we have a look at, put some context around that grep. So GPIO V3 doesn't call it lowest, it calls it low. Right, so let's see. So what we need to do is It's a little bit ugly, but this will do the job. And great, it now builds. There you go, we have a built firmware. Now, do you have a debugger and things to actually flash this and try it and see what happens?
Yeah, I can.
You can do that? All right. Well,
Yeah.
shall I prepare a pull request for this? Git CO master, git PR, make sure I've nothing up my sleeve. So we've got git CO -b PR L431 support in ChibiOS, and now modules ChibiOS, and so what we actually want to do is just this. So STM32 add STM32L431 support. Great, and then we've got to add in here, add support for TIM15, TIM-v1, add support for TIM15 for system clock. Great, and I'll push that up there, and so we can reference it and open a pull request against the ArduPilot ChibiOS for that. Added STM32L431 support. All right, and why have I got? Why is it showing me a whole lot of others? I wasn't rebased correctly. Git remote -v, git fetch origin, git rebase origin master. Origin master. I've got a whole bunch of local commits I had in my tree that I hadn't pushed up. So I'm going to discard those. And a bit more, actually. Let me see. So I2C and ported more. Yes. Okay, that should be clean then. Origin master, yes. Git push origin -f. Okay, so that should give me a sensible. Yes, that looks better. 2 commits, a low power and available MCU for yeah, I'll just do it like that. And that will do. Let's create a pull request. Great. So now what I've got to do is the pull request here in the ArduPilot tree, not in the submodule. And so ChibiOS added STM32L431 support. And I'm going to throw away those random changes to that yet again. Then there's actually very little in here. Tools added Sierra L431 board type. How ChibiOS support STM32L431. And now what we're going to do is I'm going to grab the Sierra, git add libraries AP, how ChibiOS hwdef Sierra hwdef start dat. Great, and git commit and wait for Emacs to wake up. Come on. How ChibiOS added Sierra L431 peripheral. And okay, so we've got ourselves a PR. Now changes, let's see, modules ChibiOS git diff. What have I got up my sleeve? Git status, oh, it's just got some stuff from LWIP and other rubbish. So I don't need to, that's left over from when I was playing with Sid's branch. So that, have a look over, that seems reasonable. CO431, that's just that GPIO thing and the timer. Now, yep, and that's your peripheral, which you've supplied that. So what I'll do is I'll now create a PR for this, and then you can build and test that PR and attach with the debugger and see if it works.
Yeah.
Added STM32L431 support and Sierra L431 peripheral, and co-authored by at MALL, where are you? MALLIK. No, you're not there in my list, unfortunately. What's your GitHub username?
Mallikarjun, MALLIK.
Yep.
2M, number 2.
Yep.
M.
Like that.
Yeah.
Okay, great. No worries. And AP perif and work in progress. Great. Okay, so we have a pull request. So now you just got to test it, see if it works. When it doesn't work, we work out why not. Yeah. I don't have one of the devices myself, so of course, you know, you'll, and if you hand soldered it, there's a good chance the soldering wasn't right. So we'll just have to see. But we might end the video there, and that hopefully gives you a bit of an idea how to get started on the 431.
Yeah, thank you so much.
You're very welcome. All right, I'll stop screen share and we'll stop recording. And I just reiterating that this was took a lot longer and was a lot harder than adding most new microcontrollers, because ChibiOS didn't support this one. So we had to actually add the registry, and the DMA map was different, and that it was a different format in the PDF. So there was a lot of things that made this a lot harder. In some other micros, I add a new micro in half an hour, right? Because it's just all
I mean, that's what I expected. I thought it would be half an hour.
Yeah, no, it's a bit longer than that, because this was just a little bit harder. But you know, it's taken us, I don't know how long our call's been going. It might be an hour and a half or something. It's still not terrible to add a new microcontroller in that time. But it is just that little bit harder than one that already is natively supported. And there's some things that we did in here, the double checking. I was a bit quick on the DMA map. I should actually go back and double check that that's all correct before we submit it upstream to ChibiOS. And so there are some things that we can still do a little bit better there. But I really should write that Python script to auto extract those DMA maps.
I mean, again, it depends on how ST formats their PDF, is it?
Well, that's right. We shouldn't be relying on the PDF files. The PDF files was a clever hack that we added when we first got doing ChibiOS and we got the alternate functions, but it's actually, would be cleaner to come out of the headers because they're more consistently formatted. Although we have occasionally found a bug in the headers where our extraction from the PDF was correct and the headers from ST, because those headers actually come from ST, some of them, and they were wrong. And we ended up having to edit the ST headers based on, you know, what we found. And then, to know which one was right, we had to test it by trying the DMA channel on the chip and seeing if the DMA channel actually does work, right? And sometimes in the PDF, they miss a DMA channel, like particularly suspicious when you're having a look at that. I'll share again and I'll show you. So there's pieces that are sort of suspicious in the, so if we go and have a look at this L496, right, there's the 431 here. I've actually missed that. I need to add that to the, I missed some files that new files that I forgot to add. This file I didn't add in the PR, so I'll add that now. But in this DMA map, when you see things like this, that's a little bit suspicious because usually ST try to have 2 different DMA options for each major peripheral, right? Now, this might be correct, okay, but it might not be. So what we'd need to do, we might like to double check that one, right? Now, you're probably not using I2C2. So let's just go and check whether I2C2 receive. So if we have a look, there it is there. So it's 253. Sorry, 153. It's on the first, 153. But let's see whether I2C2 receive appears anywhere else. No, it really is only one. So it is correct. So it looks like on this chip, they've got some which really are just one. But what we discovered, there was one particular annoying one where we didn't have enough DMA channels, and it turned out that there was a second DMA channel option for a particular peripheral we were using. It's just that it wasn't in the data sheet, but once you tested it, it was there. And so you sometimes find that the data sheets are actually wrong and the reference manuals are wrong. And, you know, I have been wondering about writing a program to auto-determine the DMA channels by actually loading it on the chip and then trying each possible DMA channel and seeing if it gets a timeout. Because if you basically did just something like an SPI, you can just do a bidirectional transfer on SPI, just data transfer, and see whether you get a timeout. And if you don't, then that DMA channel does exist. So you can try all possible DMA channels and work it out. But you can do similar with, you know, loop back on UARTs and that sort of thing. I think for a lot of these, you could actually write a piece of code to determine this table. It's even tempting to make this at runtime, and it actually auto-determines the DMA channels available at boot up by just trying all of them, right, and seeing and determining this at runtime. But anyway, I'll leave you to play. So the one thing I forgot was I forgot to actually commit this file, git add libraries ap hal ChibiOS hwdef scripts STM32L, great, and so there. So I'll just call that a fix up and rebase -i head, something like that, and then we're going to add in that in there. Great. And so that should fix it. It does mean that it'll take a bit longer on all of these will have been failing, although they didn't get a chance to start, but that's fixed it up. So do you want to grab that PR and see if you can build it? And let me know, or I could just give you the binaries if you like. I do tool scripts build bootloader Sierra L431. That will build and install the bootloader, and we should add that bootloader in as well into the PR. Git add tool scripts, Sierra, tools bootloaders, Sierra.bin, git commit -m, tools added Sierra L431 bootloader. Great, and if I'm going to push that, and so I could now just give you a bootloader in here. Are you all set up, ready to run it? Do you want to run it now?
Yeah.
Okay, so what I can do is pop in here and APM ChibiOS and tools bootloader. What format do you want the bootloader in?
A bin.
A bin file?
Yeah.
Okay, so all right, well, there's a bootloader for you, and I'll also give you the main firmware. Though I'd suggest just getting the bootloader first, because you actually are better off with a blank chip and just the bootloader, and not trying to load a main firmware initially, and making sure that it comes up and you can talk to the bootloader using the CAN GUI tool, right?
Yeah.
And then once that's all working, then try and load the main firmware. And you should actually load the main firmware using the CAN GUI tool, not using GDB. Because GDB doesn't do the padding rights, the CRC comes out wrong. So I'll give you a build for the main board, but I suggest that you don't actually load this main board build just yet, until after the bootloader is confirmed working. All right, so there's a main firmware, but just don't load it. All right, do you want to share screen, and you can start loading this firmware, and we'll really complete the video for people?
Yeah, I'm just getting into setting up hardware.
Okay, I will stop sharing my screen, and you can share your screen, and we can finish the bring up.
Yeah.
Great. All right.
So I mean, I usually use ST programmer.
Okay, whatever. It doesn't matter what programmer you use. Do you want to hold it up in front of your camera and show the hardware so people know what you're actually loading, or is it too secret?
No, nothing like that.
Yeah, so just turn on your camera. Have you got a camera?
Yeah.
Yeah, it just would make a nicer video if people could actually see what we're loading on and supporting. So, okay,
I mean,
there you go.
It up.
Excellent. Yep, great.
Yeah.
Classic prototype hardware. Lovely. Okay, good stuff. All right, so you can turn off video, and we'll now you can queue programmer just the bootloader, and then you've got a CAN transceiver on there and a CAN GUI tool and things.
Yeah.
Great. You know, I've never actually used STM32Q programmer. I've always used GDB. So this is unfamiliar to me because I just don't use the Windows GUI. All right, so have you got CAN GUI tool and see if we got lucky, or has it got a blinking LED? Did we set up an LED in this board?
We did, but I actually don't have it.
Oh, it's not physically attached. No, LEDs are great for bring up, really useful. Otherwise, a logic analyzer is good, but a little blinking LED gives you a lot of confidence. And if it's blinking at the wrong rate, then you know you screwed up the clock tree. So yeah, LEDs are great. Oh, using the GUI, the CAN GUI in here.
Yeah.
Okay. Yep, I always use CAN GUI tool. I find it easier for this type of bring up stuff. Hey, Sierra, it's up. There it is.
Yeah.
How about that? It worked first time. First time. And you won't have parameters because it's a bootloader.
Oh, yeah.
Right. So no parameters, but the fact that it's up on the bus at all is great. So that means that, how about that? First time porting to a new micro and it worked. There you go. All right, so let's try and load the main firmware. So let's see if we can be doubly lucky. So update firmware and point at that file. It means you got the crystal right. So many people get the crystal wrong. Because it wouldn't be bringing it up on CAN at all unless you had the right crystal there. That's why I added support for no crystal options in all our micros, because so many hardware people get the crystal wrong the first time, and then they go the second and third version with the right crystal.
So I mean, this board I had built it for a 412.
Oh, I see. So you're just modifying it to change the micro because what's available.
Most of the pins were same, and I could modify it.
Right. Okay.
Looks like we're still in maintenance.
Looks like it's stuck in maintenance mode. Now, hang on. We got to get the error code. We need to get it to display. Unfortunately, it isn't showing the error code as to why it's in maintenance. We need to. So there's the CAN GUI tool shows you the error code. So can we expand that out and look at the inspector and see what it's giving? And yeah, vendor specific code 157, but 157 is probably 157 is the number of kilobytes it had loaded. So that just means it hadn't completed the firmware update. So it's actually still waiting for that file, right? So try uploading the power cycle and then upload the file again. There's something wrong with the upload process, because it should have changed the error code to being a number between like 1 and 16 to be, fortunately we only got this one little vendor specific status code to give information on the status of the bootloader. All right, so if you connect again, you probably didn't need to disconnect. You probably could have just unpowered and repowered the device. But anyway, this is fine. And let's try loading it again. And make sure you're loading it on the Sierra, yeah. And it should now, oh, actually, before you do that, no, oh, damn it. I was gonna get you to rename the file. The length of the file name actually matters in the UAV CAN firmware. So I usually call it a.bin when I'm first starting. The longer ones will mostly work, depends on the reliability of the transport you've got. It's just that it's multi-frame versus single frame for the upload protocol, and you can find that it's less reliable with a longer file name, which is just a bizarre property of UAV CAN v0.
Again, we're stuck at maintenance.
Yeah, see if you can get it to restart. So go into menu and tell it to restart it. Does it at least restart? Okay, it is restarting.
Yeah.
All right, now go and have a look at the opcode. So go and have a look at the inspector and have a look at its opcode now. 12. Okay, that gives us something to work with. Right, so let's go and have a look at what opcode 12 is in the peripheral bootloader. Excuse me while I go and...
did we change board ID?
Add board ID. Oh, I didn't change the board ID on the hwdef.dat. So it's just telling us it's a bad board. So that's actually just a stupid error, but that's fine. At least that's actually very good. That means it's not anything more serious, and it's 1050. So I'll rebuild that for you. Okay, and board, I'm rebuilding that now, and I'll fix that in the other one. So I'll give you the new file in just a second, build. And is it file? And great, new file coming to your Discord there. So download that new file and I'll fix that in the PR at the same time. It was still 1034, so it was refusing to boot it because it was the wrong board type, which is actually exactly what it should do. Oh, we couldn't have the thing where everything went right the first time. All right, this time for sure. Well, maybe. Less than 3 boots to, or 3 or 4 boots for the first time you ring up a new peripheral would be unusual, actually. It's often a dozen or so before you find the dozen stupid mistakes you've made. We're already doing better than usual. Operational! Hey! Yeah. Okay, let's go and inspect to see what's coming on the bus. Air data, yes. Magnetic field strength. Well, have a look at the magnetic field strength, make sure it's got the I2C bus working. There you go, yeah. Magnetic field strength. You've got some pressure. That looks like reasonable pressure close to sea level. And a temperature in Kelvin, 305, that seems reasonable. There you go, you get yourself a working board. How about that? That's pretty good. So the only mistake we actually made that swdef.dat, we forgot the board ID, updating it to 1050.
Yeah.
All right, great. So if you could put a screenshot or something of that in the PR, just to show people that it's working,
I'll do it.
We'll mark it as having been tested.
GPS UART inverted. I'll swap it and.
The GPS isn't turning up?
Yeah, I think I have swapped UART.
The transmit and receive. Well, you can fix that in the parameters, because you should find you've got options. You can actually do swap you can set the swap pin if you want to. Do you want to try that? So close that.
I thought it was only on H7.
No. Most of the chips, only the F4 doesn't, but I think the L4 does, G4 does, F3 does, F1 doesn't. So go and pull the parameters and just try it and see if, let's see. I'll go and look it up actually whether it does, but I'm pretty sure that it does do it. So if you, no, it's under the serial options, or maybe we don't have those serial options exposed here in the peripheral. Yeah, we didn't expose them. Sorry, we could fix it, but we could expose that, but it's easier probably just to swap the pins. And is that like a 1 minute fix, or is that a thing you'll do later?
I'll have to do it later.
Okay, no worries. So give a comment on the PR. It's possible I've stuffed up the UARTs in some way, you know, but I think it's quite likely the receive and transmit the wrong way around. So all good stuff. All right. Well, it's been really fun. And yeah, just a screenshot of that showing it working is probably a good thing to shove in the PR to show that it does actually work. So pop into the PR.
I don't have the PR open.
I can give you a link to it. It's 18900. I'll just give you a link to it in the chat here, in the Discord chat, and then you can just click on that link. And great. Thank you very much. And great. And I will turn this into a video and then people can have a look, and it's great to end in a success. All good. All right. Well, you have a lovely morning, I guess, for you. And it's just about dinner time for me. Okay. All right. Whereabouts do you live?
I had a small question.
Yeah.
I live in Bangalore.
Well, really nice to meet you. I was the first person I've known from Banyul, I think. So
Siddharth used to work in same company which I used to work.
oh, sorry, who did?
Siddharth.
Oh, Sid. Oh, right. Okay, great. Excellent.
We both were in same company back
Right.
in probably 2017 or so.
Great. Yes. Well, Sid's doing great work on CAN. Really amazing stuff recently. Yeah, and Ethernet now too. Really good support for that. All right. Well, I'll leave you to it. Oh, you had a question. Sorry.
A question. Yeah. I have a 412 node which is running X9P.
Yep.
One issue I'm facing is the raw data logging. I have breakups in between.
Okay, you're not getting all of your data when you're logging on the 412.
Sometimes it's like 10 MB of data it logs and then it starts to break up.
Right. Okay. So how much memory have you dedicated to the logging file buffer?
I have 64K now. I mean, I've set it to maximum.
Right. Okay. Yeah, I'd probably need to look at the logs and probably with Peter.
Yeah.
Peter's the expert on the logging format, and see if there's any hints in there as to what the pattern is for losing the data. But presumably, if it's a 412, then it's an MMC SD card.
Yeah, SD card.
SDIO, yeah. So SDIO, okay. So yeah, I mean, apart from the logging size, we could try and make that more efficient too. It's a 412. It should have. You should be able to give it more than 60K. Do you have, how much memory do you have free on the node?
I mean, my firmware size was around 200 KB.
Well, that's flash. I mean, what about RAM?
RAM is 256K RAM.
So the simple thing to do is just see if you can give it more memory, right? And if with more memory it all works, then great. If not, there may be some other fundamental issue. And the way I would work on it is I would get a Nucleo board. So I've got an STM32L431 Nucleo board somewhere in my drawers here. And I'll just show you one that I was working on recently. So this is a STM32H743 Nucleo, and I was working on SPI SD cards for that, right, instead of SDMMC. Okay. So what I did was I just got a SD card breakout thing here, right? And then I wired it into the pins of the Nucleo. And then what I would do is I'd do the same thing, and I'd try setting up some dummy logging at a high rate, or a similar rate to what you're generating, and then debug it within the Nucleo, just because the Nucleo is a very convenient environment, because every pin exposed for attaching the logic analyzer. So what I would do is I would use my SAILI, and I'd stick the SAILI on these pins for the SD card, and I'd see if there's patterns, like burst patterns, see what the duty cycle is. Is it like 100% duty cycle? What clock rate? It could be that we've got the wrong clock multiplier on the SDIO there, right? And maybe we're running the clock to the SDIO at too low a rate. But to investigate that sort of thing, what you do is you put a logic analyzer on the SD card with one of these breakouts like this, have a look at the duty cycle, have a look at the clock rate you're running, see whether it's your desired rate, see whether there's gaps where at the higher levels we're just not filling the buffers to get out. That's the sort of diagnostics you would need to do to find that type of problem. The simple big stick is to use a bigger buffer, right? And if using a bigger buffer solves your problem, then all good. If it doesn't, if there's something more fundamental going on and we're running the bus too slow or whatever, then that's where you need the logic analyzer, a setup like this, and probe it and see what's happening. And it could be that we've got something wrong in our clock tree, or it could be that we're just programming the SDIO incorrectly as far as setting up the right clock. Don't know. But the first thing you do, if you know that it's not just a buffer size issue, is have a look on the bus. Have you got a logic analyzer? Have you got something like this? Like this is a, this is a SAILI Pro. Love these SAILI devices. Absolutely fantastic. Have you got something like that?
Oh, I should grab one.
Yeah, they're brilliant. There is a discount for ArduPilot developers. There's a hobbyist discount, so you can just get it under the hobbyist discount. They're not cheap, these devices. There are clones available which sort of work okay, but the genuine devices are better. But anyway, these a good logic analyzer. Oh, my video's gone all blurry. I'll turn off video and on again. There you go. See if I get video back. There it is. Video's back. So the a good logic analyzer is absolutely brilliant. It just saves you so much time. I carry it in my bag all the time and I just use it constantly. It's such good value getting a good quality. I don't use my scope anymore at all. I just use the logic analyzer now for pretty much everything. Yep.
Okay.
All good. All right. So you have a good day, and
thank you.
no worries at all. And I'll talk to you again. Let me know if that GPS starts working with the
Yes,
UART.
I'll post it on the PR.
Great.
I'll come
okay.
back. Yeah.
See you later.
Have a good day. Yeah. See you.
Right. Bye.